So now I'm going to do 2001 number 4. That's on page 53, I believe. Take a look. So we have an h function defined. They give us one h value. X can equal 0, and the derivative is given. So let's start off with part A. Part A, find all values of x for which the graph has a horizontal tangent. Let's just start off one piece at a time. Horizontal tangent, we would set our h prime equal to 0. And that would happen when x squared minus 2 equals 0, x squared equals positive 2, so x equals plus or minus the square root of 2. So those are our horizontal tangents. Determine whether h has a local maximum, a local minimum at, or neither at these values. So I'm going to go through and actually find max and min, which means I would have to set this equal to undefined. Take my denominator, set it equal to 0, and so now I can do my sign chart. I'm going to do my sign chart for h prime. My values are 0, negative root of 2, positive root of 2. There's a 0 and a 0, undefined crossed out because x can't equal 0. So to get my signs, I'm going to use my derivative, which I just boxed right there. If I put in negative 1,000, I would have positive divided by a negative, so I have a negative. If I put in negative 1, I get a negative divided by a negative, which is a positive. If I put in positive 1, I have a negative divided by a positive. And then if I put in 1,000, I have a positive divided by a positive, so I get a positive here. And then the question would be, determine whether h has local maximum, a local minimum at neither of these values, or neither at these values. So we can tell here we have a minimum, and then we have a minimum again. So both are min x equal to plus or minus root 2. Both are mins because f primed of those values, let's just call it c, or a, doesn't matter. Actually, since we use x equals, let's call it f primed of x equals 0, and f prime changes negative to positive at those points. All right. Part B, on what intervals, if any, is the graph of h concave up? So concave up means we need the second derivative. So given the first derivative up top, I'm going to do a quotient rule, low, d of high minus high, d of low, all over low squared. Now, things I really want to point out, notice I used parentheses here. It's because of that minus sign in the middle. Let's go through simplifying. We get 2x squared minus x squared plus 2 over x squared. We get x squared plus 2 over x squared. I'm going to set h double prime equal to 0 and get that x squared plus 2 equals 0. X squared equals negative 2, but that can't happen. And then we are going to set h prime, or double prime, equal to undefined, and we do that by setting the denominator equal to 0. So the only value we get for our sign chart is x equal to 0. So we end up putting this on our sign chart, h double prime. We only get 0, but remember the h double prime was 0, but since it's not in the domain, we're going to cross that out. We are going to have concave up. We're going to look for our pluses, but I'm going to be substituting into this fraction here. Notice that the denominator is always positive because the whole thing is squared. So I'm only going to use, now write it here to the right, I'm only going to put my signs into the x squared plus 2 portion. So if I put in a negative number, square it plus 2, positive number, square it plus 2. Therefore, the function is concave up on the intervals of negative infinity to 0, union with 0 to infinity, because f double prime is greater than 0. That's our reasoning for part B. Letter C. Write an equation of the tangent line at x equal to 4. So if I need the function to make a tangent line, then I'm going to need h prime of 4 which is 4 squared minus 2 over 4. So 16 minus 2 is 14 over 4. Let's simplify that to 7/2. Remember at the very beginning they gave us h of 4 is equal to negative 3 all the way at the top. Therefore I have the two pieces I need to make my tangent line. So y minus negative 3 equals 7/2 times x minus 4. Does the tangent line to the graph, let's see, oopsie, wrong button. Does the tangent line to the graph at h equal to 4 lie above or below the graph of h? So if you remember tangent lines, when we talked about lying above or below, we looked at, given concavity, if the function is concave up, the tangent line is below. If the function is concave down, the tangent line is above. So we just need to figure out what's the concavity at 4. Now I'm going to go back and steal the second derivative function that we found, which is right here. And we get, oopsie, that 4 squared plus 2 over 16. We actually get that this is positive. So I don't really care to find the value. I just needed to know it was positive. So that's one way you could have done this. The other way you could have done it is in part C, we actually had our sign chart. And if you remember our sign chart, see, we actually had that everywhere was positive. So h double prime of 4 would have been to the right of 0, therefore would have been positive. Now, since it's positive, I'm going to highlight the left picture because this is the graph where a tangent line is attached to a concave up graph. So now we know that the line, tangent line, lies below the graph. So those are your 4 parts. I'm actually going to show you the answer key for this one here. And you'll notice that all the answers should have matched for us. And you can actually go through and grade if you've done this one yourself already.